Hello everyone, welcome to the Colline IO Board video presentation. The first question to answer is what is it? It is a general purpose input-output board, mainly thought for industrial application. In this video we will revise the board itself, the use cases of the board, and we will show you a demonstration using the test software that we have developed for this board. This is the board. This is the power area. We have two connectors, the standard or normal connector and another connector mainly for the back purposes. We have here the digital output area, which is based on 6 relays and 2 outputs with optocouplers. Here we have an area of 2 inputs for pulse counter up to 5 kHz, a CAN bus, an RS232 port for displays, for example. Here we have the digital inputs, which are optocoupled. We have the area for analog outputs. This output can be in current or in voltage. We can configure it with these micro switches on the board. This is the area for analog input. Also, as before, we can configure input or voltage input with micro switches on the board. This input is for a high precision analog sensor. This is the area for the PT100 temperature sensor input, and this is the main port communication of the board based on RS485. The board, how does it work? It can work as a slave, which is, I would say, the standard or more common use of the board. In this use case, we have a master, which could be a computer or an HMI, sending and receive command using Modbus RTU protocol. The board then receive and set the outputs or read the inputs, and these input outputs can correspond to, for example, belts, pumps, motor, fans, and sensors. A special case of use the board as a slave is using a Raspberry Pi, plug it on it. Here we see the Raspberry Pi, and the Raspberry Pi is sending commands to the board, again with a serial port and using Modbus protocol. The second use case of the board is as a master. Users can develop their full application on C using the free IDE from Cypress Semiconductor Pesos Creator. In this case, the board itself send and receive commands to the input outputs. Can be a display or a touch panel connected to it using these ports. And now we are going to see the demonstration using the test software. In this image, we see the test software on the right and the board on the left. The first thing we can do is to test the digital outputs. Digital outputs are based on relays that you can change their state. For each output, there is a LED indicating its state. Here we change the state of 2 outputs and see the LEDs on. Now we can test a temperature sensor. We see the initial temperature, and if we take the sensor with our hand, the temperature increases. Now we can test the analog outputs and inputs. What we do is connect one of the outputs to one of the inputs and see when we set an output the value in the input. Internally, analog output are based in a DAC of 8 bits. So the range is from 0 to 255. 0 is equivalent to 0 volts and 255 is equivalent to 10 volts. So if we write a 0, we read as 0 volts on the input. And we see on the polymeter. If we write 127, we measure, in this case, 5000 millivolts, which is 5 volts. And finally, if we write 255, we can read 10 volts. And that's all. Thanks for watching.